Now we're actually started. Okay, good. I got to get myself a new work computer. After it updated, like the first day of the semester, it did an update, and since then it's been, there's always something with it. All right, constants. I believe that's the last, yeah, constants. So that was the last thing from that particular topic. I'm just going to adjust the camera real quick. I went the wrong way. Well, whatever. Okay. And this, just to re-emphasize what I mean, if someone sees 10.45 times sales tax, you know what that's doing. I realize the variable name here, sum bill, probably gives it away as to what it is, fine maybe. But you would at least give me, you'd concede that 10.45 times sales tax is clearer than 10.45 times 1.15. All right. Statements and expressions. Everything you've written so far in the code is a statement. A statement is you telling Python, the computer, to do something. And your programs are just a series of statements. And some of those statements are special statements we call expressions. And an expression is just a statement that does some number crunching, like a mathematical expression or something, some computation that's taking place. So print hello world, that's a statement. Assigning a variable, that is a statement. That's also an expression though, because although 5 isn't really number crunching, it kind of is. So more obviously though, something like some other variable equals some variable plus 1 times 2, that's another expression. That's quite clearly an expression. It's a mathematical expression. It's doing some calculation, doing some number crunching. That expression evaluates to some final value that gets assigned to some other variable. That's an expression. Expressions often have operators in them. And we've talked about it already, but operators are things that you've known since you're in elementary school, right? Plus, minus, divide, division, multiplication. And then there's your operands. Those are the values that the operators are acting on. We'll skip this activity because we've done it multiple times already. But let's jump to this one. Here's an activity. I want you to take a moment and write the code to convert the value of a temperature in Celsius to Fahrenheit. Write the code to do that. And if by chance you don't remember how, or you don't know offhand how to convert a temperature from Celsius to Fahrenheit, because I certainly as hell, I don't remember it, I gave you a link that'll do you a big favor. Look at that. How to convert Celsius to Fahrenheit. Look, it even gives you the little equation right there. So write the code to do that. Oops. Nope. I want you to do it with making use of variables, though. Start by assigning the value in Celsius you want to convert to a variable, and then do the calculation and assign the final value to another variable. And then when you're done, for good measure, print it out so we can see. Was it a video on converting temperature? Or was that me? It was me. Okay. Now raise your hand if you're done. Raise your hand if you'll be done in like 30 more seconds. You're just almost there. Okay, take the 30 seconds. Okay, here's my solution. Raise your hand if your solution looks more or less like this. Raise your hand if it doesn't. Raise your hand if you did it a little differently. What'd you do?
I had it as an inputable.
Yeah. And maybe that's better, right? Because now every time I want to change what the temperature is I'm calculating, I have to go change the code. Where with what you did it is you hit run, and then you don't need to change the code, you just input what you want to do. Maybe that's kind of nicer.
I was using it in the lab yesterday, and like data input. It's a lot more complicated, but
Yeah. Hey, if it worked, it worked, right? But here, it's even simpler. I just set the value, did the calculation. But of course, writing code is no good unless I know it's correct. So the way I'm going to at least convince myself it's correct is by doing some tests. And I know that 0 degrees Celsius is 32 Fahrenheit, and I ran it, and it gave me the right answer. And I know that negative 40 should be the same in both. So that's a good sign. And it's always, for good measure, let's just do one more. 10 degrees Celsius is at 50 Fahrenheit. Well, let's just check. 10 C2F. It's 50. So it seems as if it's correct. So that's good. But I really do want to emphasize, never, ever, ever just write your code, hit run, and be like, okay, I guess it's right. Never do that. That's terrible. It's probably not. Always test it. Just because it ran, I know right now a lot of the bugs you're getting are things that won't even let your program run. But just because it ran doesn't mean it's right. Always test the code that you wrote. And a little bit later, we're going to learn a little bit more of an automated way to test our code. But there we are. Any questions about that little example there, that problem? So, I mean, we've done this already. We've talked about it a number of times. Operators on different types. We saw that, yeah, you can do like addition on numbers. You can even do addition on like integers and floats, and it's happy. Multiplication, division, whatever. But you can't add a string in an integer. It's not happy. But you can multiply a string in an integer, right? We saw that one. We'll do it again real quick. Right? And that just repeated the string however many times. I'm actually curious. What happens if I multiply it by 0? Who wants to guess? I legit don't know. I've never tried this. I'm curious what will happen. I think I know what's going to happen. Yeah, that makes sense, right? Multiply it by 1. Oops. Just get it once. Yeah. Okay, cool. I wonder what happens if I multiply by like -1. All right, nothing. Cool. We can also add strings together. So the context on how these operators are used matters. The values matter, but the types of those values will impact how the operators act. Because addition on numbers is defined to work a certain way. Let me say the plus sign on numbers is designed to work a certain way. And the plus sign on strings is designed to work another way. It concatenates the string together. It just sticks them together. Now, a lot of the code we've written has been like 1 or 2, maybe 3 lines of code, right? Nothing too big. But obviously, if we're writing code to solve more complex problems, we're going to be writing more and more and more lines of code. And when we do that, we call those like those are like our programs. We call them scripts in a language like Python. They're scripts. Here we're writing our scripts in this notebook style programming, Colab right here, where it's broken into cells. The cells, they run independently. Each cell can be as big as you want it to be. It's kind of nice to have separate chunks of code if you want, or if you want them all in the same cell, you can put them all in the same cell. It doesn't really matter. But I will warn you, if I were to say like A equals 10, and then go down here and say print A, and I hit run, it gives me a bug. Does anyone want to take a wild guess why that didn't work? I didn't run the code that said A equals 10. I got to run it first, then I can run that one, and it's happy. So the values will exist between the cells, but the code will run separately. So just be warned of that. If you ever see something like that and you're like, oh, but it says it's not defined, but it's literally right there. Two things to check. One, did you spell it right? Did you spell the variable right? That can happen a lot. I saw you laugh, but it's going to happen. Don't, you just wait. Oh, it's happened, all right, even better, right? Or maybe you just didn't run the cell where it was defined. Really, you can write these scripts in any text editor you want. We're using Colab. You could do it in Notepad. You could do it in whatever basic text editor you want. All that really matters is that you have a program that can take the script and then actually like tell the computer to run it. But we're using Colab. It's a nice, good place to put it. Now, we're also going to skip this one because it was part of the lab. This is just taking a string, assigning each word to a separate variable, and then concatenating them together. We'll skip it for now. Cool. Any questions about any of that? Nothing? Okay. I know we've seen both of these things because we've all done the first lab. But one of the first things we did, the first program we wrote used the print function. That's like an output function, right? It's a way for a program to output information. It outputted it through a monitor and then we read it, but it's an output one. That's a way to get information out of the computer. There's a way to put information into the computer at runtime, and we've already all seen it in the lab. It's input. We use the input function. So if I take this, let's just get rid of this, and then I'm immediately going to print out Let's take a moment and talk about this. So first, what happened was I called the input function. And in the input function, in the parentheses, I gave it the argument, give me a value, colon, space. That's a string. And what it did is that was like the prompt for the input. You can clearly see on that first line of the output, it says, give me a value. And then I typed in, hello world. Immediately after, I printed it out. So, okay, so what's in here is a prompt. I can put whatever I want in here. Right? And it's there. Now first, notice this. I say 1, 2, 3, 4, 5. I hit enter. 1, 2, 3, 4, 5. I only had one print, but it looks like there's output on 2 lines. But you got to remember, this was output from the input function. And this right here was actually what I typed. So that wasn't really outputted there. That was just saved of what I actually entered. So be aware of that. Also, be aware, and I talked about this in lab, if you're working on Caddis, do not put anything in here. Do not do it. I don't care if it's better. Don't. Caddis will not think it's better, that's for sure. And it's because if Caddis says, I want the output to be 1, 2, 3, 4, 5, and it sees something like give me stuff 1, 2, 3, 4, 5, it's going to say, that's not 1, 2, 3, 4, 5. That's give me stuff 1, 2, 3, 4, 5. And those are not the same, therefore it's wrong. So even though you're right, you'll be wrong. So just leave that blank a lot of the times. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when I entered 1, 2, 3, 4, 5, I typed the value 1, 2, 3, 4, 5, I hit enter. Where did that value get put? I put it into the variable, my inputted value. Great. So now that value is stored in a variable, the computer's got it, and then immediately after I just printed that value back out. I got that value, whatever it was, and I printed it out. It's a simple program. Input, output. Again, this input, that 1, 2, 3, 4, 5 I wrote, was not outputted by the computer. It wasn't outputted by the program. It's just there from when I typed it in. The only thing it really outputted was this. Also, to go back to what I was saying a few moments ago, this is an example of me inputting a value into the computer at runtime. Every time, if I wrote, let me go back for a moment and say 1, 2, 3, 4, 5. Every time I hit run on this, no matter what happens, it will always say 1, 2, 3, 4, 5. I mean, obviously, right? The value has 1, 2, 3, 4, 5. I printed out, it says 1, 2, 3, 4, 5. Great. When I'm doing input, I don't need to change the code in order to have it output something different from 1, 2, 3, 4, 5. This goes back to kind of what you were doing. 6, 7, 8, 9, 0. 6, 7, 8, 9, 0. I can change what value is in the program at runtime with this input function. Another thing, it always, always, always is read in as a string. That's going to be rather obvious when I do like hello, and it says hello. But when it's a number, like 1, you might think, well, but it's a 1. Isn't it an integer? No, it read it in as the string, like the character 1, the symbol 1. But it wasn't an integer. And this could be really important because if I wanted to do print my inputted, I've already showed many of you this before. I'm just going to do it again. I'm going to add the input to itself, and of course, that would be 1 plus 1, and we all know 1 plus 1 is 11, right? We all know that that's the case. Why? Because when you take the string 1 and you concatenate it with the string 1, you get the string 1, 1, which looks like 11. If I really wanted it to be an integer, I would have to convert it to an integer. I've got a couple of options. I could be like as int my inputted value. Oops. Now I get 2. I could have done it differently. I could have taken the input, immediately turned it to an integer, and it would work. This on one line would say, read the input, immediately turn it to an integer, and then store it in the variable. Where before, I read the input, stored it in a variable, took the value of that variable, converted it to an int, and then did the sum of those two things. And lastly, if I wanted, I could have wrapped it in here as well. Where I do it doesn't really matter, but who wants to take a wild guess what I would say the best option is? I showed you 3 different ways of doing it. Which one is the better way that I would say? Convert it to an integer before I store it into a variable? Why? I'm curious. What makes you think that?
Then you don't have to do as many, like, there you're using int twice. And before you were adding in another variable.
Yep. So you're right in a lot of your intuition, but in reality, what I would have done is the first option. Maybe the second option, which was what you were saying, convert it to an int immediately. Sometimes I would do that maybe, depending on what I was doing. But a lot of times I would have done it, the first option was make another variable, or reassign the variable potentially, like this. Uh-oh. Usually, if I was writing code, I would do it this way. And I'm going to we know we've been programming a little bit for a week now, right? So now we can talk a little bit about, well, what's good code? And what good code is, you know, in the eye of the beholder, and your opinion of that's going to change throughout your careers. But right now, I'm going to say good code is code that I can look at and follow easily. In the option that you had suggested, where read the input, convert it to an int immediately, there's nothing wrong with that. It absolutely worked. We all saw that it worked. Functionally, it worked the same. But two things were happening on that line of code. Reading the input, converting it to an int. There's nothing wrong with that. But you got to remember, programmers are stupid. We're really dumb. And we like our lines of code to be as simple and understandable at face value as possible. And when you separate it, each line of code is a little bit more explicit on what it's doing. So I read the input, then I convert the input to an int, and then I print out the sum of the input with itself, yeah. The code becomes a little bit more self-descriptive, and that's a good thing. If you think to yourself, well, isn't less lines of code better? That would be true if it was 1981, when I'm really concerned about how many bytes are stored in my scripts because I'm concerned about the space and the amount of steps and how the compiler is going to convert them. There's a lot of things I would need to think about then. Thank God it's not then. It's today, and we're lucky. We're allowed to be verbose. Same thing kind of with like the variable names. If your variable name ends up being long, but it's descriptive, that's a good thing. If it's 1981 and it's long, someone might be like, you know, that variable is going to take up 2 bytes instead of like 1 now, right? And so maybe it's going to matter, but not today. Here's something that might blow all of your minds. Computer code is for humans. It's not for computers. It's for humans. Code is written by humans for humans to understand. Machine language, that's your zeros and your ones, that's for computers. That's what computers care about. Computers don't like computer code. Computers don't like computer code so much that we have programs that convert the code, which is for humans, to machine language, which is for machines. Yes?
What's the difference between the underscore and the comma? Is the underscore just like a space?
Where?
Just like in general.
An underscore versus a comma. Like here?
No, just like if you were to use a comma like in any sentence, like what's the difference between using a comma and then using an underscore?
I'm not quite sure what you mean, but I'm going to do a couple examples to see if we can figure it out. Print. Oops. No. Stop. Like that? You think? So, the difference is an underscore is like an underscore. Right? It's just there. When I have an underscore in like a variable, maybe this is what you mean. Maybe this is what you mean. If I have like equals 1, b equals 2, a, b equals 3. Is this more of what you were thinking? Yeah. Okay, so when you put a comma in a print, the comma for a function is a way to provide more arguments to that function. So with print can actually take an arbitrary number of arguments. But let's say we've got a function, I'm trying to think what math. Here, you know what? Here, hold on. The next topic, we're really going to dive into this, the functions one. But I'll give a quick explanation now. When I've got comma between values, and this is a variable, which is a value, and a print, it separates them. It'll print each thing out, separated by a space. That's how it works. Why? Because whoever wrote the print function, whenever you add more arguments to that function, it prints them all out, each one separated by space. If I were to do that with underscores, that doesn't work. That doesn't mean anything. The underscore here, this in underscore, this is like I wanted the variable named hello world, but I'm not allowed to have a space in a variable. So the way we add a space to a variable is the underscore. So the comma and the underscores in this context are used for very different things, but I know how it totally looks conflated at this stage. It will become a lot more separated, I think, next topic. Yeah. Good question, though. You stumped me for a minute because I didn't really know. Input it. Yeah. So back to what I was saying. Remember, computer code is for humans. Yeah.
So theoretically, would like something written in Java and something written in Python be the same in machine language?
Okay, it's complicated. But if we go back to 1981 and we're using our common programming languages at the time, it's complicated, but I'm going to explain it because I think it's interesting and maybe you care. If you don't, then you can plug your ears. If we have the same processor, or at least the same instruction set, which is a fancy way to say, if the patterns of zeros and ones for your processor and my processor mean the same things, then regardless of the language, it's going to get compiled to the same machine language, more or less, depending on how the compilers work, because some compilers are smarter than others. Okay, we could really go down a rabbit hole on this one, and don't get me wrong, I would be happy to do so, but I'm aware that maybe only you and me might be right now. I don't know. But in theory, yes, but there would be reasons it might be a little bit different, and that could be based on like optimization level. In today's computers, like with these programming languages like Java or Python, they work a little bit differently than like a language like C. So in C, what happens is when you write a program in the programming language C, which is ancient, especially like for computers, in the world of computers, that's like the Egyptians. When you write the code, you write your C code. You have this compiler. It turns your code into the zeros and ones that run through your processor. On a lot more of these modern programming languages, there's a bit of an extra step where you've got your processor and you've got your programming language. But the problem is everyone's processor could be a little bit different, meaning we're going to have an issue with compilers. We're going to need a separate compiler for each potential processor out there. Remember, the processor is the thing doing all of the work on your computer. And maybe your processor speaks a slightly different, like reads a slightly different language or something. I don't know. That language as like a natural language, not a programming language. So what they've done is they've created this like middle ground called a virtual machine, where you'll have a virtual machine written for each processor, but your virtual machine pretends to be a processor that's running on this processor. And so when you compile those things, you compile it to bytecode, not really the zeros and ones, but you compile it to bytecode that run on the virtual machine that's running on the processor. So there's like an added level of abstraction.
So could you use then, say like that virtual machine to almost do translation between languages?
Well, yeah, you totally, yeah. There's programs to do that type of stuff. Yep, for sure. Yeah. Now, you might be wondering, right now I'm talking about a whole bunch of different like programming languages, right? And there are a lot. Some of them are older, some of them are newer. And there's a lot of newer ones, right? Python is from like 1989, I want to say, 90. That's still old, don't get me wrong, but everyone likes it, it's good, everyone's happy with it. Some of those older languages, all of these languages that are still popular, so C is old, but it's still very popular. All of these languages have pros and cons. There's no silver bullet when it comes to programming languages. So you would pick a programming language for the job you're doing. Depending on what I'm doing, it might be easier to do something with Python versus C, for example. So there's all these different languages that exist. A lot of the older languages, like Fortran's an older one, and they basically invented like the type system, which every language uses now. And then there's languages like C, where over the decades, people have just thrown ideas at, and you've ended up with this giant pile of, that's really kind of a mess, but it works. That other people then later said, like, you know, a lot of the stuff they threw onto that pile was really good. Instead of adding it to like, instead of like stapling it onto the language, let's like actually build it into the language from foundation stuff, right? So all of these languages, like they're getting better as we go because we're learning what's good and what's bad when it comes to programming. So these languages evolve all the time. And right now, we use Python version 3. What is the current version of Python, actually? .11. We're currently using Python 3.11. So even the Python language has been evolving a lot, too, over time. So things change. And something I can do in Python 3.11, I may not have been able to do in Python 3.12, and so on and so on and so on. So just a little bit of that. Now, there's nothing wrong with the language C, but the problem with the language C is it requires a lot of, how could I word this? It requires a lot of like extra busy work that you don't really need to think about today. But then you get some people that are like, no, but I'm hardcore. Like modern languages are like driving a car with like along a dangerous mountain with guardrails. And then if I'm in C, I might be like, who needs guardrails? Only bad drivers need guardrails, right? But usually people who are saying that actually are the ones that need the guardrails the most. Yeah. And then you can play that game forever because like, oh, well, real programmers programming with a machine language, zeros and ones, right? Because like, how far back do you want to go in abstraction? You know what? Never mind. I'm going to stop. This is now, I'm seeing, yeah, it doesn't matter. Input. So, okay, and we checked the type. I just said this, it's always written as a string. If I really want to convert it to an int, I can convert it to an int like I just showed you. Give me a value, my value as string, convert it to an int, my value is int. Stored it in a separate variable. There we go. I just showed you this, but it's in the content there. Changing types. Yeah, you can change types within reason where it makes sense. If I have A equals 1, 1. No, how do I want to do this? A equals 1. A, type A. Print int of A. So this would be example right here. This would be an example of one line of code doing a lot of work. If I'm writing code in some software I'm writing, I wouldn't really do it. But for quick and easy example right now, it's fine. So yeah, I took oh, they're both ints. I wanted to make it to a str. Yeah, there I had the integer 1, and then I converted it to the string 1. I can convert the string 1 to an int. Right? It's fine with that. I can also do it with a float. Yeah, it's fine. But notice that it added like the 0.0. I could turn the int into a float. It's fine to do that. I can turn an int into an int. Who wants to guess what that's going to do? Nothing. It doesn't really seem to do anything, but hey, it's a thing. But of course, if I go and say hello, it's going to go, okay, A is hello, print out A. We see the hello, the type is A. Then it gets to here and it goes, well, hold on. You told me to convert the string hello into an int. Well, what is that? That doesn't make any sense. I can't do that. And yeah, it can't. And if for any moment you're like, oh, the computer's dumb, it can't do it. Well, no, then you do it. Convert the string hello to an int. And of course, then you realize, okay, yeah, I don't know. That's not a thing. And it would work the same with a float. Of course, you can't convert that to a float. At least I don't think so. Okay, good. Yeah, you can't do it. Awesome. Cool. Any questions about that? Any question? Okay, let's take a moment here and say, are there any questions about anything we've learned so far up until now?
Yeah, so I always have an issue when I'm programming. I always get the non-type errors where it's not an integer, float, or string, and I never know why that is.
So, can you tell me an example of what you did to make that happen?
For sure. So I was looking ahead and I went to like that pounds to kilograms project thing.
Yep.
And I decided to it's LB for pounds equals float input into weight in pound. And then kilograms is just pounds times 0.4539. Then I said print your weight in kilograms is print kg. And it always says error because one is a float being 0.4392 and then pounds is just nothing.
So you more or less have this so far, is that right? And then, so what did you put in here though?
Their weight in kilograms, say, print your weight in kilograms is, then I just did another line under it because I can't get them in the same line. I just said print kilograms. So, yeah.
So mine is working. So I'm curious, maybe you've got like a slight little typo, but none type.
Yeah.
Did you, when you hit run, does it prompt you?
Yeah.
Okay, so,
Prompts me and then it gives the error.
yeah. LBS, LBS, is it spelt the same? Can you?
Yeah. Sorry, I just recently got it working, but it was because I kind of copied an old code.
Ah, okay, so I could probably, Okay, everyone close your eyes for a moment. Just there. There. Oh, I gotta run it. Did you see something like this?
Yeah.
Okay.
Yeah, non-type.
So, here's what it's saying. I had to change the code a little bit to make it work, to make this bug come up, but I had a feeling I knew what was happening. Here's what's happening, is we've learned about 3 types so far: strings, integers, floats. There's another one called none type. And integers can store any integer. Strings can store any arbitrary string of characters. Floats can be any floating point number that we can represent in the computer, like we kind of saw the other day. There's issues there. There's another one we're going to learn about soon called a Boolean type. Anyone hear that word before? Boolean? That's a type, but what's interesting about that type is that type can only ever have 2 values, either true or false. Some languages that'll be either like 1 or 0, but true or false. So it's a type, but it's only allowed to have 1 of 2 values. And there's another type called none type that's only ever allowed to have 1 value, that is none. Long story short, this is saying you've got something of none type, which is a whole other type, and you're trying to multiply it with float. In a similar way where you can't add an integer to a string, it's like you can't take a stir and add it to an integer. I'm not defined for that. It's saying I'm not defined for this none type. Now that none type pops up in various situations that we will see shortly. But interesting that you found that one. That's a good one. But this really is the same bug as like I can't add a stir in it. It's just the type is a little bit different. But at the end of the day, same diff. All right. I'll see you all whenever the next class is.